Welcome to Survey Math. So as carpenters, often we have to do a little bit of a survey to find elevations of the land surrounding us, whether it is for an excavation or maybe you're doing a small project, building something in someone's yard, even as simple as a sloped driveway or a sloped surface, and you want to build really nice and level um, like veggie garden beds on top or flower beds. For anything where you ever have to find any differences in elevation, this is the kind of math you do. Now, in the real world, you don't have to use a builder's level. You can also use a laser level and just your tape measure. There are lots of ways to do it, but the theory of how you're figuring out the different elevations is all the same. So let's have a look here. We have a little bit of a circuit. So we have a benchmark that is always a point that is given to us in our math problems, or in the real world, you might set a benchmark and you always want it to be something that is immovable, like a people hole cover or a fire hydrant. You don't want that to just be a stake in the ground in some soil that can potentially move because you want to make sure that you can refer back to it. Our benchmark elevation is usually most often set to 100 meters. That means we can go up or down in measurements or in elevation heights without going into negative numbers, right? Imagine you're using a fire hydrant as your benchmark elevation and you set it to 0. Well, now you're taking elevation measurements in an excavation. Now we're in negative numbers, and that makes everything more complicated than it needs to be. We don't need to add that. So, and on the right here, you can see a chart where everything kind of like our booklet and where we're going to do our filling out. So we've got our stations, that's our benchmark, A, B, C, D, etc. We have backsites. So when we look back to a known elevation to find our new height of instrument, we have our height of instrument that we figure out, and then we have our interim foresights and regular foresights. So our interim foresights, those are foresights. So we've done our backsight, we've established our height of instrument, and now we're turning it. And because you've done such a nice job setting it up nice and level, you can turn it all the way to and fro, and you're looking out along that same level line. And now we're looking forward to new spots and we're actually trying to find that elevation. And for example, A and B here, we're not doing anything with them math-wise. We just maybe need to find those points, but that's why they go into the interim foresight. Whereas C, you can see that after we have to move our instruments, we're using C as a turning point, which means we want to use it as a foresight. That way we can keep things a little bit more organized. And that is really important when you do survey math, because you need to be able to refer back to it. And in this kind of circuit here, we're actually going to come back to our benchmark. So hopefully by the time we're done, we will come out at 100 meters of elevation again when we're done. Now, let's start. We are starting with our first station, which is the benchmark, and the elevation is given to us, which is 100. Now this is all in meters. I'm not going to write meters into everything here and make it look clustered. I'll just pop in the numbers. So now we have a backsight reading, correct? That is given to us here, 1.469. So we put that in the backsight column, 1.469. Now check this out. We have a known elevation of 100. We're taking a reading, so someone is holding a rod and someone else is looking out. So elevation plus our reading will give us our new height of instrument. And for that reason, I always put a plus up here for a backsight, because we always need to add that one. It's just to help me remember. And then for the foresights, we do the opposite, and we'll get that in just a second. I put a minus. It makes it easier for us later. So our height of instrument, benchmark elevation of 100 plus our reading. So let's pop that into the calculator. 100 plus 1.469. Important that you double check your numbers. It's really easy to accidentally put in the wrong number and then you hooped. So height of instrument is 101.469. 1.469. Wonderful. Now we can turn our instrument and we can look forward to point A. This is an elevation we're trying to find, but we have our height of instrument minus our reading will give us our elevation. So let's pop those in here. We have our station A. We have an interim foresight, 0.219. And does that make sense? So we're looking out at a level line. Our rod is sitting on elevation A on that point. So where that reading happens is the 0.291. So if we take our height of instrument minus that reading, that will give us the elevation for A. So in your calculator should still be the height of instrument, 101.469 minus 0.219. And that should get us an elevation of 101.25. Wonderful. Now we can look ahead to B. Same thing here. We have our height of instrument minus our reading will get us the elevation for B. And again, it's an interim foresight. So 1.326. And you can see the way it's drawn, the reading for A was 0.219, and here the reading is 1.3 something, which means B needs to be lower than A because the number that we're reading on the rod or the tape measure is higher. So let's figure out our elevation. So height of instrument, 101.469 minus our reading, 1.326, gets us 100.143. Wonderful. Now we can look forward to C. Now check this out. After C, we're going to move our instrument. So instead of the interim foresights that we don't want to or don't need to deal with again, we want to put it in our foresight compartment here. But same thing, we're taking a foresight and it's 0.948, and now we want to find the elevation. Again, taking our height of instrument minus our foresight will give us the elevation. So 101.469 minus 0.948. 100.521. Wonderful. With the height of instrument, make sure you put in the right number in the calculator again. It's really easy to leave the elevation numbers that you figured out in the calculator and use those to keep going, and that is a very common mistake. Now, we're moving our machine. You're leveling it nice and neat. Now we have point C that is a known elevation because we just figured it out. So we're going to take a backside to C. So elevation plus our reading will give us a new height of instrument. So let's pop in that backside right here, 1.138. So our elevation, that's still in the calculator, 100.521 plus our backside of 1.138 gets us our new height of instrument. So 101.659. Wonderful. Now we can move ahead to the next point. We've got D, E, and F, and those are all interim foresights. So let's pop those in here. 1.284. So we take our height of instrument. Remember, it's a new height of instrument because that's where we're looking from, minus our reading to get us the elevations. So 101.659 minus 1.284. It's us an elevation for D of 100.375. Great. Now moving on to E, we have another interim foresight, 0.435. And again, taking our height of instrument, haven't moved, minus our reading will give us the elevation of E. 101.659 minus 0.435 gets us 101.224. And one more, we've got F, one more interim foresight, 1.435 1.247. And same thing again, it's just repetitive, but you have to continue to pay attention so you don't do anything wrong and lose points in silly ways. Height of instrument minus our reading gets us the elevation for F. 101.659, right? Putting in your height of instrument back in the calculator, minus 1.247 gets us 100.412. Okay, now we're looking forward to G. Now let's see if there's anything special here. Well, it looks like we have a foresight, and then after we're moving our instrument again, so we're also going to use G as a backsight, which means it's called a turning point, which also means that it has to go into the actual foresight column. And I'll show you why exactly at the end here, because we can do a little math to double check if we did things right. 1.193. So again, height of instrument 101.659 minus 1.193 gets us the elevation for G, 100.466. Now we are moving our instrument. We're picking it up, we're moving it, and we're taking a backside to G, which is now a known elevation. We just figured it out, and we need to set up our new height of instrument. So how do we do that again? Well, we have a backside reading of 1.241, and we take our elevation plus our reading to give us a new height of instrument. And that's why I always have the plus and the minus at the tops here to help myself remember, should I ever lose my brain. So we have our elevation still in the calculator, plus 1.241. And that gets us a new height of instrument of 101.707. And now we're coming back to the benchmark. That's not how you write that. Here we go. Benchmark. And it's giving us a reading, right? That's the guy up here, 1.707. And that's going to be a foresight for us because it's not a turning point, but that's just where we're finishing up. 1.707. So let's figure out the new height of, the new elevation. We have our height of instrument minus our reading will give us the elevation. So 101.707 minus 1.707 should give us 100 on the dot. So check this out. We started at the benchmark and we ended at the benchmark. And thankfully, whew, the elevation is 100 for both, which means we did our math correctly. Now, sometimes or often you might not start and finish at the same point. So there's a different way that we can double check our math. And that's why we have a backside column and a foresight column. So I want to add up the backside column on their own, and I want to add up the foresight column on their own. And when we subtract one from the other, it will give us the difference in elevation from our starting point to our end point. Okay, so let's put this in the calculator. You do it too. So 1.469 plus 1.138. See, easy to make mistakes. Plus 1.241. In the backside column, that comes to 3.848. Okay, so now let's do the foresight column. 0.948 plus 1.193 plus 1.707. Oh, no way. Also gives us 3.848. Now, taking one minus the other gives us 0, which is excellent because, well, our elevation difference between our benchmark from the beginning to the end didn't change, right? So there we go. And that's how she's done. I hope that's helpful. And this is the way you can always do it. for any of the ones that you pop in. And if you ever lose your brain, just remember that you can actually logic your way through, right? You can draw this out. Even sometimes it might only give you a worded question where you have to figure out something. So always draw yourself a picture and always make yourself a chart. It really helps to keep things organized and make sure that you're doing it properly. Super duper helpful.